In this video we will study an example where um, a ball moves in a circle, and it's a very standard example of a circular motion problem. So you tie a ball with a string, and then you swing it around till it starts to go in a circle of radius r. So L, radius r. So these are given to you, and then you're supposed to find the tension that's in here, tension, the magnitude of tension in the string, and you're supposed to find the speed which the ball must be going, which is constant. So you can use these numerical values if you like, and maybe you want to take a moment, try it out yourself, and pause the video. So okay, say you've worked, and then I'm going to try to solve the problem. Maybe you can pause any time you like if you're looking for some hint. Okay, so you know, in a circular motion, so first thing to notice is this is a uniform circular motion, meaning when it's going in a circle, when it's over here and this is the center of the circle, the acceleration is pointed in that direction. That's the net acceleration, which is actually centripetal acceleration. It has a magnitude formula. If the speed is v and the radius of the circle is r, then that you know, its direction is that at this point, direction is that, and magnitude is this is the magnitude. So the net force will be in that direction. So we need to figure out what the forces are. Well, there are only two forces on this. So if I look at this, one of the force is pointed vertical. If this circle was in this plane, then this force is perpendicular to that plane. So this is the weight. Weight is perpendicular to that. So that's mg in that direction. And the tension is in that direction. Tension is if I go directly above, this is R and this is L, then the tension is in that direction. Let's call it magnitude T. So we can we're looking at this particular instant, we can assume there's a vertical plane like this. There's a vertical plane in which the motion is occurring, and mg is in that plane and t is in that plane, and there is this angle here which we can make use of. Let's call that angle theta. We can make use of that because you can see if this is r and this is L, then sine of theta is r over L. So this you can make use of if I need that. Okay, so these are three vectors that we need to work with. Well, acceleration is then direction. So as has been the practice, we can use this direction to be the direction of positive x-axis, and this direction to the positive y-axis. So you can see what the components of the F equals ma will be. So I have F net equals to ma. We'll have decomposing in into x and y components give along the x components. What I'm going to get? I'm going to get acceleration is going to have positive, so mass v square over r. So that's for the ma and the x component. The force will go here. Mg has no x component, it's perpendicular to x. So tension will be the only one. So if the tension is that way, I draw a 90-degree on it. So I need if you do all the way to there, that will be easier to work with, and because 90 is right here. So I need, that's the amount I need for the tension. So if this is the angle and this is the hypotenuse is capital T, then this will be tangent sine of theta. So that's going to be T times sine of theta, and sine of theta in this triangle will be R over L. So that we got. So that's one equation, and we can just call this equation number 2. Along the y direction, we have no acceleration, so the right side will be 0 on the y equation. The left side, I have an mg is negative, minus mg, and tension will have, if I drop on the y-axis, I need this. So if this was a positive, so it's going to be positive t, and they're going to sine, it's definitely is going to be cosine. This is theta, this adjacent, so t cosine theta. Okay, so these are two equations that we can work with. Of course, we have sine of theta like that, and you'll say, what's the cosine of theta? Well, cosine of theta will be in this triangle. You can see I need this side divided by that side in the size. This side, so if I have, this is r, and this is L, and this is theta, so this will be square root of L squared minus R squared. So cosine theta will be square root of L squared minus R squared over L. That will be cosine theta. So this is 3 and this is 4. So we what's given to us is m, r, and from there I can get the theta and L. So we need to find v and t. So over here I actually two unknowns. When I look at here, this is given to me, I can figure out cosine theta, so I can get t from here. So from 3 I can get the magnitude of tension, which will be mg over cosine theta, which will be, if I write down cosine theta over here, so it will be mg L over square root of L square minus R square. So that's I got for t. From 1, I can use this t into 1, so I get mgl over square root of L square minus R square for the t. For sine theta I get R over L, so this L will cancel out here, and on the right side we get m v square over R, and I can see the m cancels out, so m cancels out also, which means the speed will be independent of the mass of the ball. So different size ball will have the same speed as long as they go in the same circle. So I can put on the other side. So rearranging gives me v square equals to g r square over square root of L square minus R square, and v is the speed, so I take a square root, I just keep a positive values, and so I'll get a square root of g r square over square root of L square minus R square. So with this we have the answers. Now we can use calculator to get the numerical values. Well, to get the numerical values, it's sometimes better to actually work with sine theta and cosine theta. So for instance, we say sine theta is r over L, and so we could have found this already. So r was 0.25 meter and L is 1.2 meter, and so from there we will get 0.25 divided by 1.2, so 0.208, and cosine theta, so I need square root of L square minus R square to get, so L square is 1.2 square minus 0.25 square. So let's see, I clear this. 1.2, I get a square minus 0.25 square, and I get a square root of that, and that gives me 1.17. That will be meter, so I'm just going to ignore the units right now. So I got that, sine theta is that, and then we have t is mg over cosine theta. So let's see, so t is going to be, mass is 0.4 kilogram and 9.81 meter per second square, and divided by cosine theta. Cosine theta will be this divided by L, so 1.17, 1.2, and so I'll get a 0.4 times 9.81 times 1.2 divided 1.17, and that should give me 4.0 Newton for tension. And for V, you can say it's the square root of GR, and so you have a, let's just put the numbers that we have already. So G is 9.81, R is 0.25 square, and this stuff is 1.17, so that should be 0.25 square root of 9.81 by 1.17, and so let's see, 9.81 divided by 1.17, and take a square root of that times 0.25, and I get 0.72 meter over second for this speed. Okay, I hope you got the same answers, and this very standard problem. We'll see you in another video. Bye.